everyone. Today we're going to be talking about landscape textures. But before we get into that, there are two things that I wanted to show you. A bunch of you put in the comments that there was this cool software called PureRef that I could use for organizing my reference footage. And I've actually downloaded that and I'm using it right here. You can see that I have all of these different reference images and I have organized them and laid them out into a couple of different categories. And this software is fantastic. So I want to thank those of you that pointed this out to me. I'm going to be using it for reference from now on going forward. So thanks a lot for that tip. The next thing that I wanted to show you is when we talked last week about landscapes, I really forgot to talk about using reference for the shape of the landscape. And so since last week, I went ahead and collected some reference images that show the shape of the stream that we're trying to create. And the thing that I wanted to point out to you is that I noticed that the stream is pretty flat, and if it does have some sides, they're kind of gently sloping down. The stream that I created in the middle of the video last week had these really steep sides, but in all these reference images I'm looking at, you can see that the sides are kind of gently sloping. And then the other thing that I noticed from the reference is that a lot of these streams have these tiers or terraces where the water is mostly going flat and then it kind of drops down. And so I decided to work on my height map a little bit using these two features that I noticed from the reference. So let's jump over to Unreal and I'll give you a quick update here on the scene that we've been creating. Okay, so here we are, and here's the height map, and I worked on it a little bit off camera just to match those elements that I noticed from the reference. So here we have our stream, and you can see that I made the sides a little bit more gently sloping instead of being quite so steep. And I also added those tiers or terraces that I saw in the reference images. So going back and looking at that reference was really important, and it was key to me understanding that we needed these kind of gentle slopes and also these nice tiers. So the way that I did this is in the landscape mode, I used the flatten tool that we talked about, and I flattened out these areas, and then I used the sculpt tool to kind of push the landscape up, and the smooth tool, and then I used the flatten tool again, so I was able to create these tiers that you see. Okay, now the next thing that you'll probably notice is that our landscape is really boring looking with this gray checkerboard, and we need to fix that. So we need some textures and materials for our landscape, and that's what we're going to talk about today. So we need to take a look at our reference again, and you can see that I've collected this section of reference that kind of has to do with materials or textures that you might apply to a forest stream landscape. So over here on the left I have some roots of trees, some dirt and leaves on the ground, lots of moss. And then over here on the right I've got lots of images of cobblestones in a stream bed that are kind of wet looking. So these are the kinds of materials that I'm going to be looking for, or that I'm going to try to create for myself. So at this point, I need to find these textures, and where can I do that? Well, there's this really amazing resource that Unreal users have, and it's Quixel. And the reason that it's amazing is Quixel goes out and they capture real-world materials, and they process them for you. And then normally they charge for these things, but because Epic owns Quixel, they offer them for free to anyone who is using Unreal, which means you can download these things and use them in your projects completely free, as long as you're willing to pay Unreal's licensing fees if you sell your game. But if you're just a hobbyist and you just want to build your environment, These things are completely free. There's no catch to this, and you can just use these all you want, which is amazing. Now, in order to use Quixel's materials, you need to install a piece of software called Bridge. And what I'm going to do is put a link in the description that explains how to install Bridge. And so we'll switch over and take a look at Bridge now. If I just go to the home area, you can see that there are some amazing looking materials. They have materials here. They have 3D assets. They have 3D plants. They have decals. They have all kinds of assets that you can download. And not only that, but this software, Quixel Bridge, makes it really easy to download and immediately import the assets directly into Unreal in a single step. And I'll show you how to do that. So the first thing that we need to do is find some surfaces. And in our reference, we identified needing some mossy ground, some forest ground with maybe dirt, leaves, and roots, and then also some cobbly stones. And right away, I'm seeing one down here that looks like it might work for us. So I'm going to click on this. And here's an asset that we can probably use. This is, it's called Mossy Creek Stones, and that matches pretty closely to some of the images that we were looking at in the reference. So if I want to grab this, and you can see it's purchased, which means I've already downloaded it. Now it says purchased, but like I said, I didn't have to pay any money for this. All I had to do is, when I set up Quixel Bridge, give it my Unreal account, and it knew that I was able to use these images for free. So if I click here on download settings, you'll see that I have it set to download 4K textures, and for material preset I have custom. And the reason for that is normally you would pick Unreal, but there's a specific set of images that I want to use that's a little bit different from the Unreal default. So I'm downloading the albedo, which is the color. I'm downloading the displacement. I'm downloading normal, AO, and I'm also downloading cavity. And I'll explain why in a minute. And then I'm also downloading roughness. So this is the set of textures that I'm going to grab. And I will hit download. Now for you, if you hadn't grabbed these yet, it would say download, but for me it says re-download because I already have them. And then the other thing that you need to do is come over here to the export settings. And we need to make sure that export, and then these are the settings that it's going to use when it brings the textures into Unreal. So we're going to use 4K textures in JPEG format. I'm bringing them into the Unreal Engine. And the engine version is version 4.25, which is the version that I'm using. Here's the installation folder and also the project location. And I'm going to click on this and just show this to you here. It's important that when you find your project location, you go to the folder, which is the name of your project, but then also to the content folder so that these will be installed into the correct place. And then the first thing that you need to do is download the textures and then come to export and hit the export button, and that will download them and then it will import them into Unreal for you. So let's switch over to Unreal and I'll show you what that looks like inside Unreal itself. Alright, so once you import the assets into Unreal, you'll get these textures. You get an albedo, you'll get AO, cavity, displacement, normal, and roughness. And it will also create a material for you. So I can take this material, and if I just select the, I'm going to switch my mode back to select here. And if I just select the landscape and come to details, you can see that I have a landscape material here. And right now it says none, which is why my landscape is just completely gray and checkerboard. So if I grab this material that Quixel created for me automatically, I can just drop that into my landscapes material slot and give it a minute to compile the shaders. And now You can see that it's super duper tily, but if I zoom in and get really close, you can see that now my terrain is covered with these wet, mossy rocks. And it looks really, really bad if we zoom way out like this, but as long as we stare at the ground really close, you can see that I have a very realistic looking material on my landscape. So the next thing that I want to talk about is a little bit of performance optimization, because we just downloaded 6 textures here. You can ignore these other textures in this material function for now. We'll get into that later in a different tutorial. But right now, so we have albedo, AO, cavity, displacement, normal, and roughness. We have 6 textures. And what this means is every time our material is created, it's sampling 6 different texture maps. And we've talked about this in previous videos, but one of the most expensive thing that a material does is sample texture maps. So the more texture maps you have, the more expensive your material is. And we're not just going to have one material in this on this landscape. We're going to end up with a bunch. We talked about the dirt and the roots and all of those different materials that we found from our reference. And so we're not just going to be sampling these 6 textures. We're actually going to be sampling 6 for every one of those. So we may end up with 24, 30, 36 texture samples, and that's a lot. So we need to find a way to combine these textures into fewer. So the next thing that I'm going to show you is how to take these 6 texture maps and pack them into just 2 texture maps so that we can be a little bit more efficient. Now I've already done this. You can see that I have this texture here called Moss Rock CR and this other one called Moss Rock NOH. So what I want to do next is show you how to create those. And this step I've actually done in Substance Designer, but it's also something that you can do in Photoshop. So I'm going to show you how to do it in both pieces of software, so that if you want to do it in Photoshop, you can, or if you want to use Substance Designer, you can. Okay, so in Substance Designer, I've created a new graph, and I've brought in my textures as resources, and then I just dragged them out and applied them to the graph. So here are all my textures. And then what I've done is I've merged them together. So here is my color texture. You can see down here, that looks pretty nice. And here's my roughness texture. Now I put the roughness texture in the alpha channel together with the color texture. So this is an alpha merge node, and the color texture goes in RGB and the roughness goes in the alpha channel. And I called this texture underscore CR, standing for color and roughness. And then this other texture that I'm going to create has a normal map, and it's only using the red and the green channel of the normal map. And I've packed the red and green channel into the red and green channel of the final texture that I'm creating. And then I took my ambient occlusion map, which looks really nice on this particular material, and I also took my cavity map, and I used this blend node to multiply them together. You can see I have my blend mode set to multiply. So I'm combining my cavity with my ambient occlusion, and the result ends up looking like this. And I put that into the blue channel of my final texture, and then my height map I'm storing in my alpha. And this final texture I'm actually calling an NOH map, and NOH stands for normal, occlusion, and height. Because I've got my normal in the red and green channel, I've got my ambient occlusion and crevice maps multiplied together in the blue channel, and then I've got my height map stored in the alpha channel. So normal, occlusion, and height. And so I'm calling this texture an NOH map. And I save both of these out as a TGA, and then I re-import them into Unreal. So you can see that my originals here, there are 6 maps, but in Unreal it ends up just being 2. So here is my CR texture, and here's my NOH texture. Now let's switch over to Photoshop and I'll show you how to do that there. Alright, so here we are in Photoshop, and you may notice that I'm using an ancient version of Photoshop. Yes, I'm using Adobe Photoshop version CS4, but that's just because I really don't like Adobe's subscription model, so I've just stuck with a version of Photoshop from forever ago. So here is my color texture, my albedo, so I'm just going to copy it and make a new one, or a new copy of that. And then I'm going to come over here to the channels and make a new channel so that it has an alpha. And I'm going to take my roughness map and copy that and paste it into the alpha channel. So now this channel is ready. It has the color in the RGB and it has the roughness in the alpha. So I can save this out as a CR map. And for my normal map, I'm just going to take this map and copy and paste it. Make a new texture, paste it in. And now I need to come to my, I need to create a new channel for the alpha. And I'm going to take my height and paste it into the alpha channel. And now for the blue channel, I need to combine my cavity map and my AO map. So I'm going to take a copy of my AO map and paste it in here to this new copy. And I'm going to copy my cavity map and paste it here as a new layer. So you can see over here I have a layer which is the cavity map on top of the AO map. And then on this top layer I'm going to set my blend mode to multiply. So here if I turn this layer on and off, you can see what that's doing. It's kind of a subtle thing, but I'm combining those two together using a multiply. Then I'm going to make a new layer on top, and if I hold down the Alt key and open my menu here and pick Merge Visible, it's going to take everything from layer 1 and layer 2 and merge it onto layer 3. So now layer 3 here is my AO map multiplied with my cavity map. And I'm just going to select all, copy, and then I'm going to paste that into my blue channel. So now my red channel and my green channel are my normals. My blue channel is the AO and cavity map multiplied together, and my alpha channel is my height map. So I have my N, O, and H. All right, so I'm ready to save this texture out, and I'm just going to save it as a TGA. Be sure that you save it as 32-bit TGA so that it preserves the alpha channel. And then I'm going to import both my CS map and my NOH map back into Unreal. Alright, now that we're back in Unreal and we have our CR map and our NOH map, the next thing that we need to do is make a material that unpacks these. Before we do that, let's take a minute to look at the material that the Quixel Megascans provides for us. You can see that it's creating albedo, roughness, normal, and displacement. So it's sampling these 4 textures individually, and we don't have our ambient occlusion or our crevice map sampled. There isn't an option to do that. And so what we need to do is make a material that's similar to this, but that unpacks our 2 CR and NOH maps and creates a material out of that. And just for purposes of a demonstration, I'm going to go ahead and make a new material here, and I'm going to call it my test material, and I'm going to show you how we can go ahead and unpack these. So here's my material, and I'm going to go ahead and drop in my CR map and also my NOH map. So unpacking the color and the roughness is pretty easy. I know my color is in RGB, so I'm just going to wire that directly into base color. And I know my roughness is in the alpha channel, so I'm just going to wire that directly into roughness. And now we need to unpack our normal, our ambient occlusion, our crevice map, and our height. For the normal, I only have the R and G, and I need to create the Z. And for that, I have a node called normal derive Z. I think that we've talked about this before on the channel, but basically what you can do is plug your R and G channels into the XY vector. And what this is going to do is it's automatically going to calculate the Z component for you based on the X and Y. If you know that the normal is normalized, so all three components together give you a unit vector length of 1, you can calculate the third channel if you know the first two. And so that's what this node is doing for us. So if we plug our RGB in here, then it will create the Z for us, and the result will be a normal that has all three channels correctly together. Now, there are a couple of pretty important steps that I've missed, and so I need to actually step back a little bit and explain these. First, I'm going to open my normal map here and show you a couple of settings. So when I imported my NOH texture, it's really important that you set the compression setting to BC7, that you set sRGB to off. And so this is going to store your texture in linear space, compressed using BC7. It's not set as a normal map because it has data that's not normals, and so I'm setting it to BC7 instead. And what that means is generally if you set a texture to be a normal map, it's going to expand the range of the normal map. The texture is stored in 0 to 1 space, but a normal map needs to be expanded from from 0 to 1 to the -1 to 1 space so that it can be a vector instead of a color. And normally, if you set your compression to a normal, when you bring your normal map in here, it's going to automatically do that expansion for you. But in my case, I know that it hasn't done that. And so I'm just going to take my RGB here, and I'm going to make a component mask. So I'm just taking the R and G, which are the X and Y of the normal, and I'm going to multiply them by 2, and I'm going to subtract 1. And this is going to expand our normal from the 0 to 1 range to the -1 to 1 range. And now I need to use the derive normal Z function. So I'm going to pass this into the X and Y, and then you can see that now I've got my correct normal vector here. All right, the last thing that we're going to do here is unpack our blue channel, which is our crevice map and our ambient occlusion map. And to do that, I'm just going to paste in some nodes that I got from another shader that I've been working on. So basically, what I'm going to do here is I'm going to take our blue channel and plug it in right here. And I'm using cheap contrast to increase the contrast of the map. And then I'm multiplying by 0.5. And my goal here is to separate the ambient occlusion from the crevice map. I know that ambient occlusion itself is usually not using the dark values. And so if I take this blue channel here where I've multiplied ambient occlusion and crevice together, and I connect it to this node which is a max of 0.3, this is going to get rid of the dark values and just return the brighter values. So that is going to give me my ambient occlusion, and I can just take that and wire it directly into ambient occlusion here. And I know that my crevice map is normally just showing the crevices, and I can get rid of the brighter values that make up my ambient occlusion by using a combination of cheap contrast and then setting the contrast value to 1.5. So that's going to give me my crevice map. Then if I multiply that by 0.5, what this is going to give me is the specular value. So I can take this and plug it right into my specular channel. Now, a lot of people say you don't really need ambient occlusion and specular, but I really like to use them. I think it adds just a little bit of extra. Let me show you this render ball here, and I'm going to disconnect specular and ambient occlusion, and you can see that there's some detail lacking here. Like, there are reflections in areas where there shouldn't be reflections, and the ambient light is just too bright. And so if I add back in my specular value and also my ambient occlusion, you can see that it improves the surface quite a bit using specular and ambient occlusion. And we're able to do that while still just doing 2 texture samples. So I feel like these 2 elements really add a lot to the material. And so that's what we're going to do. What we've actually done here is, if we take a look at the material that Quixel is providing for us, we're actually doing 4 texture samples with their material, and we're not using the specular or the ambient occlusion. But with this material that we just created, we're only doing 2 texture samples, but we're able to do base color, specular roughness, normal, and ambient occlusion. So I feel like we've been able to make something that both looks better and is more efficient. And so the last thing that we need to do today is we need to take what we've done here and convert it into a function so that we can use this process over and over, because we're not just going to do this with our mossy material here. We actually have a whole bunch of landscape materials that we need to use this same math on to unpack them from the CR and NOH textures into a more simple format that Unreal is able to deal with. So we need to take this set of nodes that we've done here and create a material function so that we can do this over and over again. Okay, here is the material function that I've created, and I've called it mi_unpack CR_NOH, because the purpose of this function is to take an input CR texture and an input NOH texture and unpack them so that we have base color, roughness, normal, specular, ambient occlusion, and height. So we need all of these elements in order to make our material. We start out with those 2 textures that we created, and we're unpacking this to all of the individual elements of our material. So with our CR texture, we use the RGB component mask, and then we output that as the base color. And we use the alpha component mask to output the roughness. This is just what we've done before. Then for our normal, we mask out our red and green channels. We multiply 2 and we subtract 1. And then this part of the graph I've done just a little bit differently. Before I was using derive normal Z, but instead I'm just appending a 0.4 for the Z component of my normal, and then I'm normalizing. And what this does is it's a little bit cheaper than derive normal Z, but because I'm using a value of 0.4 here, it's going to punch up my normal and give it just a little bit more kick. And then you can see that I'm outputting my normal here. And then to split out my specular map and my ambient occlusion, you can see how I'm using the cheap contrast node with a contrast value of 1.5. And then I'm multiplying by 0.5 to change my crevice map into a specular map. And then I'm outputting the specular there. And then for the ambient occlusion, I'm just taking the blue channel of my NOH map using a max of 0.3 and then outputting ambient occlusion. And then I'm taking the alpha channel of my NOH map, which is my height, and outputting my height. So now I can use this function in a new shader. And let's go ahead and do that for the last thing that we're going to do today. We'll switch back to my test material. And instead of this, we're just going to go ahead and add in our function. So if I use my filter here and I type unpack, there's my MI unpack CR NOH. I'm just going to drag that right in. And now you can see I have a spot where I can plug in my CR map. So I'm just going to do that, and make sure that you plug in the RGBA because you need all 4 channels. And also for the NOH map, I'm going to drag in the RGBA. And now I can output my base color, my specular, my roughness, my normal, my ambient occlusion, and the height I'm not going to plug into here. We're going to use that later for both blending material textures on the landscape itself and also displacement and tessellation, but that's going to come in a different video. So now I can delete all of these nodes, and what those nodes were doing previously are now encapsulated in this nice unpacking function. So I make my graph quite a bit more clean. Now, one more tip that I have, if you have these output or input values and they come in a different order, if we switch back over to our function here, I'll click on these input nodes and you can see that there's this sort priority value. So my CR input texture has a sort priority value of 0, and my NOH has a sort priority value of 1. And then over here, my base color has sort priority 0, my roughness has 2. So you can give these the numbers in order to order them correctly. So I know I want base color first and then specular color second, so it's got a sort priority of 1. So these sort priority numbers determine where they show up here. And I really like to order these in the same order that they're going to plug in over here. So you might want to spend just a little bit of time and organize things that way. All right, so now I have my test material. I'm going to go ahead and save this and switch back to our map. And so now you can see we've got a really nice version of our mossy ground material that we created. And now the material is actually optimized quite a bit because we're only doing 2 texture samples and getting 6 pieces of data, whereas before we were doing 4 texture samples and just getting the 4. So I know that this wasn't super exciting and we didn't make a whole lot of progress toward making our scene, but what we just did is really foundational to creating the rest of the landscape material. I'm just going to switch back to the Quixel Bridge again and show you the other materials that I went ahead and downloaded. So I downloaded this one called Stony Forest Ground, Riverbank Rocks 2x2M, Forest Ground, Mossy Ground, Ground Roots, Mossy Creek Stones, and River Stones. So these are the materials that we're going to be using in our map. And so what you should go ahead and do is download these from the Quixel Bridge and go ahead and process them just like I did by creating the CR and NOH maps. And then we're going to create, in the next episode, we're going to create materials for each of these and then combine them together into a single material so that we can paint layers on our landscape, so that we can put each of the individual materials in the correct places into our landscape. Right now, it just looks pretty crazy because it's all one uniform material. But next week, I'm going to show you how to combine all of these individual materials into one and then paint them in the correct locations. That's going to be pretty cool. So be sure to come back next week. In the meantime, if you haven't yet, please subscribe to the channel, and I'll see you next week, everybody.